What if our entire story of the universe, the one we've been telling for decades, from the Big Bang all the way to today, is wrong? Not just, a little bit off, but fundamentally missing a huge piece of the puzzle. We're going to explore a pretty revolutionary idea that suggests we're on the very edge of a whole new understanding of the cosmos. Okay, think of this like a cosmic detective story. For decades, we've had one main suspect for how the universe works, but now new clues are showing up, and they just don't fit the old narrative. So we're going back to the scene of the crime, the universe itself, to see what the evidence is really telling us. You see, for the last few decades, cosmology has been absolutely dominated by one triumphant story. It's called the Lambda-Cold Dark Matter model, or Lambda CDM for short. And for a very long time, it really did seem like a flawless theory. And I am not exaggerating here. The LCDM model has been a monumental achievement in science. It accurately predicted and explained this incredible range of observations, giving us a coherent, compelling story of our cosmic origins. The whole thing is built on these four pillars you see right here. You've got the Big Bang as the origin story, the cosmic microwave background as its ancient echo, and then two really mysterious ingredients, dark matter and dark energy, acting as the cosmic glue and the cosmic accelerator. These four ideas have been the absolute foundation of cosmology for years. So here's the thing. Even the best, most successful stories can have plot holes. And as our telescopes have gotten more and more powerful, we've started to see a few that are just, well, they're too big to ignore. And as you can see, two fundamental cracks have appeared in our story. First up, the expansion crisis. Basically, when we measure how fast the universe is expanding using light from the early universe, we get one number. But when we measure it using stars in the modern universe, we get a different, faster number. And they shouldn't be different. They just don't agree. Second, we've got the early galaxy problem. Telescopes like the James Webb are finding these massive, fully formed galaxies way back at the dawn of time that, according to our model, just shouldn't exist yet. It's like finding toddlers who are already 6 feet tall. It just doesn't make sense. So how do you solve a mystery when your main theory can't explain the clues? Well, some scientists are proposing a pretty radical new approach. Forget the theory. Forget all our assumptions and just start over with nothing but the raw data. Here's the problem they're trying to solve. It's something called the methodological trap. When we get new data, we can't help but interpret it through the lens of our favorite theory. This just confirms our own assumptions and reinforces that original theory, even if it might be wrong. It's this vicious cycle of confirmation bias that can make it almost impossible to see what the universe is actually trying to tell us. And that brings us to the really powerful principle behind this whole new method. It's a simple but profound shift in thinking. Let the evidence lead without any preconceived notions. You build a story from the clues. You don't try to force the clues into a story you've already written. And this is the new process in action. It's called the empirical-first workflow. It starts by just cataloging raw observations, facts, not our interpretations of them. Then you map out the non-negotiable boundaries that any theory has to explain. Only then do you start generating the simplest possible explanations. The final steps are absolutely crucial. You design unique tests that can actually tell them apart. And then you let the universe decide the winner. Theory comes last, not first. So what happens when you apply this radical new method? When you strip away all the assumptions and just listen to the data? Well, strange, wonderful, and completely new ideas for how the universe actually works begin to emerge. The data points to three prime suspects in our cosmic mystery. And these aren't just little tweaks on the old story. They are fundamentally different frameworks for reality, each one popping up as a simple explanation for the facts that we're observing. All right, suspect number one is the embedded system. The easiest way to think about this is to imagine our entire universe is like a hot cup of coffee sitting in a giant, cool room. What we call cosmic expansion is really just our universe cooling down and settling into balance with its larger environment. It's a really elegant idea where expansion isn't some explosive beginning, but just a process of settling down. Suspect 2 is called the geometric phase. For this one, picture a crumpled up piece of paper that's slowly smoothing itself out. In this view, expansion isn't things flying apart in space, it's the very geometry of space itself uncurling and relaxing into its final flat form. And our third suspect is maybe the most mind-bending of them all, the information unpacking model. This framework suggests that the universe began as a sort of maximally dense cosmic zip file. And what we experience as time and expansion is just the process of this information decompressing into physical reality. This could actually explain those impossibly mature early galaxies. They just formed during a super rapid initial unpacking phase. Now, I know these might sound like wild philosophical ideas, but this is where it gets really exciting. These frameworks aren't just stories. They're scientific hypotheses that make concrete, unique, and most importantly, testable predictions. It's time for a showdown. You see, the gold standard of real science is something we call falsifiability. A good theory doesn't just explain what we already know. It sticks its neck out and makes risky predictions. It gives us a clear way to prove it wrong. And that's exactly what we have here. And this right here, this is the showdown. We have 3 decisive tests. First, let's look at the giant empty voids between galaxies. The embedded system predicts there should be a faint floor of hydrogen atoms in there, while the other 2 predict they're totally empty. Next, the actual shape of these voids. The geometric phase predicts they should be slightly cigar-shaped and kind of aligned with each other, while the others say they should be random. And finally, the information unpacking model predicts a hard cutoff, a point in time beyond which we can never see, no matter how powerful our telescopes get. So, why is this revolution happening right now? Why are we suddenly questioning decades of scientific consensus? It's because we've hit this really unique moment in the history of science. We're in a perfect storm of opportunity. First, we have an unprecedented amount of data. We're talking over 100 petabytes from telescopes like JWST and Euclid. Second, we have artificial intelligence that can sift through that data and find subtle patterns a human could never spot. And third, we have cloud computing that lets us test millions of ideas in parallel, compressing what would have been decades of research into just a few months. And this is bigger than just cosmology. What we're really looking at is a new template for discovery in any complex data-rich field, from neuroscience to climate science. It's a new scientific manifesto for the 21st century, and it's all built on one core principle: data before doctrine. So, what does this all mean for us? It means we're living at a genuine inflection point. We're moving away from telling the universe how we think it should work, and instead, we're finally building the tools and the mindset to let it tell us its own story. The age of assumption is ending. A new age of discovery is just beginning. The universe has been talking all along. Now, we are finally ready to listen.